Hey guys, and welcome back. I'm Steven from Tech Overseas. Today we are diving into one very important and yet confusing concept in JavaScript, the closures. Now, if you want to become a web developer, you not only need to understand what closures are, but you need to master how they work. And that's why in this video, I will explain what closures are, how they work, and why they are so important. All right. So a closure is a function that remembers the variables from the place it was created, even after that place has finished executing. Now think of a closure as a notebook. You write a note in the notebook and then you hand over the notebook to your friend. Now your friend writes another note and then close the notebook. Now even if your friend takes the notebook home, they can still see and add to your original notes whenever they open it. However, you cannot see or change the note that your friend wrote after they took the notebook home. Now let's start with a very basic example. We are going to create a function in order to create a counter, okay? So this function will have a variable count and it's going to return to us a function. Now this function can either be anonymous or it can be a named function. For the example, and so it makes more sense, we are going to use a name function. This function will have the only purpose to increment the count from the create counters function scope. So we say count plus plus, and then we are going to console log count equal count. Now, two things to notice. The first one, the increment function is a closure because it remembers the count variable from the create counter function scope, okay? And the second thing is that even after the create counter has finished executing, the increment function will retain access to the count variable, allowing it to update the count and then console log the count. Now, when you call create counter, it actually prepares everything and it gives you back the increment function. So the increment function isn't run right away, and that's why this setup lets you decide when and how the increment function is being used. So let's see in practice. Let's say that we have my counter equals create counter. So we call create counter and we assign to my counter whatever is the return value of create counter. And in our case, the return value of create counter is actually a function and it's our closure. Now, if you want to use the increment function, what you have to do, you have to actually call my counter function. So what you are going to say, you are going to call it multiple times. And when you save, you can see that it actually increments the count 1, 2, 3, 4, 5. The reason why I said closures can be confusing is because many people think that closure are a function returned by another function, and that is not the case. And this is a common mistake. A closure is any function that remembers the variable from the scope where it was created, even after it has finished executing. And this is very important because, for example, we can actually transform our create counter function, returning our function, into something different. So we can say that our create counter function is no longer going to return the increment function immediately. It's actually going to return an object where the object is going to have the increment property like this. And so now if we want to increment our count, what we have to do, we have to call myCounter.increment. And if we call it multiple times, you can see that we have the same result, 1, 2, 3, 4, 5. So this is very important to understand. Now let's have a look at a more practical example to show you how closures really work. One example I really like is actually using a bank account. So imagine you want to create a bank account, okay, and you have an initial balance. So you can deposit money, you can withdraw money, you can check your balance. And only the bank knows your balance and you can only interact with your balance via the bank account. So let's go ahead and create this function. Function create bank account, okay? We will pass an initial balance just like that. And we will create a new balance which will default to our initial balance. And if we don't have an initial balance, we can just default to 0. Now we're going to create three methods: deposit, withdrawal, and get balance. So we can say function deposit, it will take an amount. And inside here, we can actually check if the amount is greater than 0. We can increment our balance. We can also console log, for example, we have deposited that much money in the account, and the new balance is actually this balance, which is the old balance plus the amount. Now, if the amount is less or equal to 0, we can simply say invalid deposit amount. Now, for the withdrawal, okay, this looks good. So if the amount is greater than 0, and if the balance is above or equal to the amount, we can actually reduce the balance by the amount. We can log a success, otherwise we log a failure. And now in order to get our balance, we can simply console log the balance and we can return our balance. And so what you can see right now is that we have three methods. We have deposit, withdraw, and get balance. And so those three methods are actually closures. And they are closures because they can use the outside variable, which is let balance. And so every time we will use these functions, they will retain the value of the balance value. We can go ahead and actually return an object from our create bank account. And so this object will actually return our three methods. So the deposit, the withdraw, and the get balance. So now in order to create a bank account, we have to use the create bank account function. So we can go ahead and say constant my account equals create bank account. And so we pass $1,000 in order to credit our initial balance. So you start with an initial balance of $1,000. Now let's say that you decide to deposit $500 more into your account. So you can go ahead and say my account.deposit $500. Now next you decide to withdraw $300 from your account. So my account dot withdraw, and we can actually withdraw, let's say $300. And finally, you want to check the current balance of the account. So you can say my account.getBalance. So you can see that in this scenario, we are actually calling this function back to back, but you don't have to. Like I said, the closure will return access to the outside variable. And so you can actually use this function anytime, anywhere you want. But in our case, we just use them back to back. So if I save, we get deposited 500 into the account. The new balance is 1,500. Withdrew 300 from the account, the new balance is 1,200, and finally we get the balance, and the balance is actually 1,200. So you can see that these three methods, deposit, withdraw, and get balance, are actually closures because they retain the value of the outside variable, which is here balance. Another important example is actually currying. So currying is a way to transform a function so that it can be called with one argument at a time. And so closures makes currying possible because they remember the initial argument. So let's go ahead and see how currying works. So for this example, we are going to define a function add that takes an argument a, and it returns another function that takes an argument b. And all it does, it actually returns the sum of a plus b. So let's go ahead and say function add. It takes an argument a, which is a number, and it will return a function b. And all it does, it's actually going to console log of a plus b. Okay, so we can save. Now, in order to use this, we can say, for example, add 5, and we can call add 5. So if I save, you can see that nothing is happening. Remember, a closure does not run unless it's being called. And so add 5 here is not calling the closure, it's actually returning the closure. So what we are doing, we are returning the closure, and we assign this closure to the add 5 method. So now if we want to use it, we can say, for example, add 510, we can say add 520, and we can say add 530. Here, it's actually going to add 10 to 5, 20 to 5, and 30 to 5. So if I save, we get 15, 25, and 35. Now, closures can sometimes lead to unexpected behavior, especially in loops. So let's look at how closure work in loops and how to handle common mistakes. So let's go ahead and remove this code. So let's create a very simple for loop where we say I equals 1, I less than 6, and then I plus plus, okay? So we are going to use an asynchronous function with the set timeout, and the asynchronous function is going to run every 1 second, and we are going to console log I. So as you can see right now, we have 1, 2, 3, 4, 5, okay? Now, if we use var, for example, you can see that we no longer have 1, 2, 3, 4, 5, we have 5 times 6. And this is because var is function scoped, so it's globally scoped. So each timeout callback actually shares the same reference to I, which ends up being 6 after the loop finishes. So there are two ways to fix this, and the first one we just saw it. So the first one is to replace var by let, and by doing this, you can see that we get 1, 2, 3, 4, 5. And this is because let create a new scope for each iteration. Now, the second way to fix this is to actually use var with an immediately invoked function expression. Quick disclaimer, this is not something you will actually use, it's just to show you how closures work. And so we can actually replace let by var here, and we can actually use our immediately invoked function expression instead of calling directly the set timeout. So here we have our function, and we actually pass I, and here also we pass I. In this case, it actually creates a new function and it executes it immediately, passing I as an argument. So by doing this, each iteration of the loop creates a new scope and I has a different value, and that's why it works. Now, if I save, you can see that even though we are using var, we still have 1, 2, 3, 4, 5. And that's it, guys. Now you know that by understanding and mastering closures, you can significantly enhance your JavaScript skills by writing more efficient, modular, and maintainable code. Now, I hope you like this video. If you have any questions or topic you'd like me to cover next, leave them in the comments down below. Thanks for watching, and until then, happy coding.